Hi there, this is Krish Agarwal from 2BSc DS, Christ University Lavasa. This is a video on what we have learned in a course, Introduction to Data Science till now, and I'll be representing what I have understood in depth. Firstly, what is data science? Data science is an interdisciplinary field which uses scientific methods and algorithms to extract insights and inferences from data, whether the data is unstructured, semi-structured, or unstructured. It is related to data mining, machine learning, and big data. There are some prerequisites of data science or for data science, which are machine learning, database management, statistics, mathematics, and computer learning. Then we move on to business intelligence versus data science. Firstly, business intelligence uses structured data, whereas data science uses unstructured data. Then we have the source. In case of business intelligence, it's a warehouse, and whereas in data science, it can be seen in forms of logs. It is analytical versus scientific, and stats and visualization versus stats, visualization, and machine learning. And the main important part or distinguishing feature is business intelligence uses past and present data, whereas data science only uses present data to make data driven decisions for future. Moving on to AI versus deep learning versus machine learning. They are all interrelated. Machine learning consists of AI consists of machine learning. Deep learning consists of AI and machine learning. AI enables machine to mimic human behavior. It basically give, gives computer the ability to think like a human, whereas machine learning uses statistical methods to perform tasks, or you can say it uses inferences rather than insights. And deep learning is a subset of machine learning that helps to perform tasks with less human intervention, like neural networks. The use of data science in real world, here are some of the following. It is used to derive business challenges like sales and marketing, fraud detection in social media, travel and healthcare, etc. In today's world, the sources of data are mainly of two types: primary and secondary. Primary data means collecting data for the very first time from the source itself, be it some sort of questionnaire, survey, etc. And secondary data is using the primary data or the already collected data once again. Now we move on to what are the types of different databases. We have flat files, which stores information in text or binary form, and the data which is not related to each other. Then we have relational databases, or RDBMS as we say. It arranges data in rows and columns in a very sorted and arranged manner. Then we have data warehouses, collection of data from multiple sources. And in further which we have three types of data warehouses: enterprise, data mart, and virtual warehouse. Then we have transactional databases, collection of data based on date and time, and the capability of rolling back or undoing a step, which is very much useful in our banking steps, where we get to cancel the transaction and change the amount. Then we have multimedia databases, which stores data in forms of videos and pictures. Then we have biological data, which is used in medical field like protein analysis or gene analysis. Then we have spatial database, which stores your geographical information. Example is Google Maps. Then lastly we have time series databases, which is used for real-time analysis of the data. Then we move on to data sampling. Data sampling is basically a process in which you select out a small subset of the population, wherein population stands for the total amount of uh, subjects on which the sampling is done, and making experimenting those particular sample and deciding an outcome for the entire population. And it is mainly of two types: probability sampling and non-probability sampling. Probability sampling is selecting the sample or that subset on a random basis and on an unbiased scale, and it is of four types. Simple random, when a sample is randomly selected from the data. We have cluster, when the whole data is divided into small groups on basis of some sort of uh, performance or feature, example location, age, etc. Then we have systematic, every nth dividing every nth individual, and that nth is the fixed value. Then lastly we have stratified, whereas the whole population is divided into small groups representing the entire population. Coming to non-probability sampling, it is more faster and practical because the scientist who is conducting an experiment already knows what the sample he she has to choose, which makes the process much faster. And it is also of four types. We have convenience, based on the ease and the convenience, like standing outside a school to distribute pamphlets is one of the examples. Then we have judgmental. First, in judgmental, we first understand the audience and then come to some sort of inference or form the inference, like are you interested or not. Then thirdly we have snowball, which is the topic of collection is highly sensitive, like who are affected by floods, menstrual cycle of women, etc. And lastly we have quota. Selection is based on preset standards, like only people more than the age of 50 can participate. And as the data around us is constantly growing, there are a particular sets of data which are so large in volume that our traditional data analyzing methods can't be used upon them, and such data is known as big data. And its sources are application data, machine data, social data, and enterprise data, which collects the data in mainly three forms: unstructured, semi-structured, and structured. And while we discuss about big data, there are five V's attached to it: volume, the volume of data or the size of the data is increasing day by day or second by second. Then we have velocity, the speed in which the data is increasing is huge. Then we have veracity, the uncertainties and inconsistencies in the data. Then variety, different types of data, semi-structured, structured, and unstructured. And lastly we have value, the true meaning of the data. Adding to these five V's, we have two more V's: variability and visualization, where variability is how the data changes over time, and visualization stands for uh, after coming to an inference, make visualizing that data using graphs with the help of applications like Hadoop. uh, there are a few challenges, not few but a lot of challenges to big data. Some of its some of or major of it is very hard to manage because it is so large in volume. They have complex structure, they have inconsistencies, the data is missing, you have to complete fill in the data. Then the time to process this data is huge, and lot of errors while execution is seen. Then we move on to storage. HDSF is a platform for storing your data, for storing the big data. It solves the problem of solving, and it is the following is how it divides the data in form of nodes and smaller chunks and stores them in clusters, which helps in data scalability. And while processing this data, we use map reducing, which provides parallel processing data in a distributed file system. Now next Now next comes machine learning. Machine learning is a scientific study of algorithms and statistical models to perform tasks using inference rather than instructions, and training models to make predictions. It is a type of AI which allows a machine to automatically learn the past data without programming explicitly. Machine learning, there is a hype around today's world where everybody, is in the field of data science and wants to learn machine learning because it has a bright future ahead. But that's just the practical part to it. Everybody doesn't know the three main parts of, or the sub parts of machine learning, which are supervised, unsupervised, and reinforcement learning. Firstly, supervised learning, uh, it includes labels in datasets to predict outcomes accurately. You collect the data and segregate them on some sort of labels and features, and it furthermore has two more divisions to it, which is classification and regression. Classification also has more further subdivisions into it, which is binary, which has only two labels, ones and zeros, or normal and abnormal. Multi-class, having more than two class labels. Multi-label, two or more class labels like bicycle in a photograph. And then we have lastly imbalanced, refers to classification tasks where the number of examples in each class is equally distributed. Then coming to the second part of supervised learning, which is regression. We divide or segregate the data between some sort of linear regression model or machine learning algorithms. Secondly, we have supervised learning. It does not segregate data on some sort of label or features, but some sort of performance and more accurate measures, and it is also further divided into three more subparts, which is clustering, association, and dimensionality reduction. In clustering, we divide the data into smaller clusters on the some sort of performance. In association, we associate our data on some sort of performance or a relationship, and in dimensionality reduction, we cut out the unnecessary or unneeded data. And lastly or thirdly, we have reinforcement learning. It is also known as a feedback mechanism where we provide the machine learning model whether the outcome is right or wrong, and based on that it develops and becomes more accurate over a time. It has reward based learning that works according to trial and error. It is a type of machine learning method where an intelligent agent interacts with the environment and learns how to act within that. For example, robotics, game AI, you have skill acquisition and real-time decisions, etc. Then there are certain types of machine learning models, mainly three models: overfitting, underfitting, and balanced. Overfitting means your model performs very well during the training but not during the testing. Underfitting stands for when it performs very poorly in training but well during the testing. And balanced is, it is balanced throughout both training and testing, which is what every machine learning model or the company tries to hit to. And there are also challenges, limitations to these models or machine learning per se, which are poor quality, overfitting, underfitting, and it can't say if the data is available or not. Users lack of expertise, and it becomes more difficult in explaining the models to the business companies. We also use machine learning in EDA, exploratory data analysis, where we make graphs for better insights to the common or general public. Then we come back to SQL versus no SQL. SQL stands for not only SQL or not SQL, to be put in more better and precise words. It is a database management system where the data isn't necessarily supposed to be stored in rows and columns. It is easily scalable and very flexible in nature. What does scalability mean? Uh, it basically uses sharding for horizontally scaling and can handle huge amounts of data because of this property known as scalability. The data in NoSQL grows itself over the period of time. Also, it has high availability. Auto replication feature in NoSQL databases make it highly available because in that case of failure, data replicates itself to the previous consistent state. Then there are everything has challenges to it. So the challenges to NoSQL have are management challenge, meaning it is not easy to manage large amounts of data even with big available tools. Data management in NoSQL is complex as it uses non-relational databases. Then we have large document sizes, like databases like MongoDB and CouchDB store data in JSON format. It has descriptive key names as the document size has increased. Then we majorly have four types of NoSQL databases. Firstly, document based database. Secondly, is key value store. Third is tabular or white column store. And fourth is graph store. Why would anyone use NoSQL if there is a SQL? Firstly, when the data is changing over time and is of a not specific structured format. Secondly, to keep up with the growing data, one needs to scale the database on a regular basis. Thirdly, the constraints and joins on a database level are not required. And finally, the relationship between the stored data is not important. Uh, then we have SQL versus NoSQL. Why would anyone choose a particular model and why? The language. SQL has a fixed and dynamic schema. SQL has a fixed or static or predefined schema, whereas NoSQL has a dynamic schema. SQL is best suited for a hierarchical database, whereas NoSQL is stored for non-hierarchical database. Scalability. In terms of scalability, SQL is vertically scalable and NoSQL is horizontally scalable. And SQL follows the ACID property, which stands for atomicity, consistency, isolation and durability, whereas NoSQL follows the CAP property, which stands for consistency, availability and partition. Last topic of this video is ethics versus morality. Ethics is a social construct or a framework of rules and regulations which is accepted by the society, and whereas morality is something what an individual thinks is right or wrong on her individual basis. To this topic, we have 5 C's, starting from consent. Uh, Whenever we access a website, they should have a consent on whatever amount of data that they are collecting. Uh, while giving a consent, we also need to have the clarity of what data we are handing them over. Generally, we just have to accept those terms and conditions, and we don't know what these terms and conditions are. We need to get a proper idea of that and the amount of data that we are giving. In most of the cases, we are forced to tick that box and give the necessary data to them. With this, we come to third point, which is control. Are we actually in control of the data that we are giving the country? I don't think so. uh, but now, as we are moving forward in time, we see a lot of websites are giving us a choice of selecting necessary cookies and additional cookies for their pattern and their data collection. And fourthly, we come to consistency slash trust, where you know a company has to prove its trustfulness over the years, so that its customers and newcomers see it as a opportunity to share their data with them while accessing their website. For example, the Cambridge Analytica and Facebook data leak, which happened quite a couple of years back, where Facebook sold its data to Cambridge Analytica, which in turn used that data to, uh, use it in political aspect to change voters' point of view towards a particular party and helped win Donald Trump. And lastly, we have consequences. If we are ticking certain boxes, only that amount of data should be collected, and when collected it should just abide by that rules and regulations of that particular company, its users, and the law. If any if even a single rule is breached or broken, the company is supposed to follow its consequences or can be sued by the users. There are also, like example, the Children's Online Privacy Protection Act, the COPA, protects children and their data. Likewise, there are laws to protect specific sensitive data sets like Genetic Information Non-Discrimination Act, the GINA, was which was established in 2008 in response to rising fears that genetic testing could be used against or their families. So here are a few cases, and with this I would like to conclude this video. Thank you, Dr. Father Joshi, for teaching us this subject, the theoretical part of a stream, in such detail and keeping it excited, making it an interactive session throughout the way.